Okay, so we have our triangle. We know that this is 60 degrees, and it says that he wants to figure out what the other sides are. He knows that the angle is 60, but he doesn't have a calculator, so what else can he do? So then he says, I think I see a shortcut. If I flip it over here, so if you see I've kind of flipped this over here, this becomes 60 here. What used to be 30 here comes 60 here, and what I have now is an equilateral triangle. So if this is 2, this whole thing is 2, and thereby this guy here is equal to 1. And I know it's equilateral because these guys are both 60, and these guys add up to 60 because 30 plus 60, or 30 plus 30 is 60. So that's how I can find A. Now to find B, I can just use Pythagorean theorem, right? So I have 1 and a 2 and a B, and I solve. So 1 squared plus B squared is equal to 2 squared. B squared is equal to 4 minus 1. I square root both of them, and B is equal to the square root of 3. So what we want to now look at is, will this approach work for all triangles? So if I have, if I have a different triangle, like, for instance, a right triangle of like 20 and 70, will that work? Well, no, because then I will have a 40 and a 70 and a 70, and that won't work. It's not equilateral. So then what if it's a different size? Oh, I forgot, way back up here. Could it be reflected across a different side? If I reflect it across this side, this is going to be 30, 30, and 120. That won't work. If I reflect it across this side, it's not even a triangle. So this only works if you reflect it over the long leg of the right triangle. So I have a bigger one now, and so I hopefully recognize that if I kind of look at it like this, this 8, this whole thing is 8, so this is 4. So then I use 8 squared is equal to 4 squared plus B squared. I get B squared is equal to 64 minus 16 is 48. Now when I square root that and simplify, I get 16 and 3, which gives me root 3, but then that's 4. So this is 4 root 3. And we go, look, wow, that's kind of cool. This was 1 times root 3 to get this one. This is 4 times root 3 to get this one. What if it's always? Well, let's look and see. If this is x, and this is 60, remember this whole thing is 2x. So I'm looking to find out what that side is there. Let me make this a little bit bigger. And I have x squared plus b squared is equal to 2x quantity squared, careful. So I get b squared is equal to 4x squared minus x squared. B squared is equal to 3x squared. Then when I square root them, I get plain old x times root 3. So that answers the question that no matter what this is, this side is going to be this side times root 3 to get that one. So using that information, if this is 15, this is 30 because it's double, and then this one is this side times root 3, so 15 root 3. Now, is this a 30, 60, 90? This is 3 and this is 7. That's not a 1 to 2. If I flip that over, that is 6. So no, it's not 30, 60, 90. All right, let's go ahead and look at the back side. Up at the top. So that covers the 30, 60, 90. Now these are the 45, 45 rights. So for this here, this side is 1 and this side is 1. So I'm looking for this side here. So 1 squared plus 1 squared is equal to b squared or c squared or whatever it is. So I get 2 equals b squared and square root square root. This is equal to root 2. This is really kind of like a half square. We can also call it a 45, 45, right? Either one's fine. And so then I can do my math again, and I figure out that this one is 20. And if I do my 20 squared plus 20 squared and square root that and all that stuff, I am going to get 20 roots of 2. And here I'm going to get 5 squared plus 5 squared, square root that. I get 5 roots of 2. So we look here, we go, wow, that is pretty darn cool. What if it was x and x? What would this side be? X squared plus x squared is equal to c squared. So c squared is 2x squared. And if I square root that, I get x, plain old x, times the square root of 2. So that tells me that for 45, 45 right, these two are the same, and this one here is times root 2.